Chapter 3, Vectors and Motion in Two Dimensions. Section 3.6, Motion in Two Dimensions, Projectile Motion. Projectile motion is an extension to two dimensions of free-fall motion. A projectile is an object that moves in two dimensions under the influence of gravity and nothing else. As long as we can neglect air resistance, any projectile will follow the same type of path. The vertical motions of the two balls are identical. The vertical motion of the yellow ball is not affected by the fact that the ball is moving horizontally. The horizontal and vertical components of an object undergoing projectile motion are independent of each other. A heavy red ball is released from rest 2.0 meters above a flat horizontal surface. At exactly the same time, a yellow ball with the same mass is fired horizontally at 3.0 meters per second. Which ball hits the ground first? A, the red ball hits first. B, the yellow ball hits first. Or C, they hit at the same time. The answer is C, they hit at the same time. The horizontal and vertical components of an object undergoing projectile motion are independent of each other. The vertical components of acceleration a sub y for all projectile motion is just the familiar minus g of freefall, while the horizontal component a sub x is 0. A 100-gram ball rolls off a table and lands 2.0 meters from the base of the table. A 200-gram ball rolls off the same table with the same speed. It lands at a distance of A, 1 meter, B, between 1 meter and 2 meters, C, 2 meters, D, between 2 and 4 meters, or E, 4.0 meters. The answer is C, 2.0 meters. The motion is independent of mass. The angle of the initial velocity above the horizontal, above the x-axis, is called the launch angle. We calculate the initial velocities in both the x and y direction using trigonometry. The x component, initial velocity, is the initial velocity times the cosine of the angle theta, or the launch angle. The initial velocity in the y direction is the initial velocity of the launch times the sine of the launch angle. The ball finishes its motion moving downward at the same speed as it started moving upward. Projectile motion is made of two independent motions, uniform motion at constant velocity in the horizontal direction and freefall motion in the vertical direction. The horizontal and vertical components of projectile motion are independent but must be analyzed together. An object is launched into the air at an angle theta to the horizontal. After launch, the vertical motion is freefall. The vertical component of the initial velocity is the component of the initial velocity vertically. The acceleration is due to gravity and points down, negative. After launch, the horizontal motion is uniform unaccelerated motion. The horizontal component of the initial velocity is the initial velocity for the horizontal motion. The acceleration does not change, and the horizontal velocity is constant throughout the flight. The kinematic equation for projectile motion are those for constant acceleration motion vertically and constant velocity horizontally. The time must be the same for both sets of equations since we are describing the motion of a single object. A hunter spies a monkey in a tree, takes aim, and fires. At the moment the bullet leaves the gun, the monkey lets go of the tree branch and drops straight down. How should the hunter aim to hit the monkey? A, aim directly at the monkey. B, Aim high over the monkey's head. C. Aim low below the monkey. I'm not going to tell you the answer. Think about how you would answer. We will do the experiment in class.